We all think we have a pretty good handle on what energy is. We use it, we store it, we can feel it when we work out. But what if our most basic gut-level intuition about it is just wrong? What if energy isn't a thing at all? What if it's just a calculation? Okay, let's really dive into this, because it gets weird fast. There's this framework called TCGS-SEQUENTION, and it makes a pretty radical claim. It suggests our universe is basically a static film strip. Every single moment, the past, the present, and the future, it all already exists, all at the same time. Now, if that's true, how in the world can we use energy? If nothing is actually changing, what does it even mean for a battery to discharge? So right here, this is the fundamental clash of ideas, side by side. On the left, that's our reality, right? We use energy, our phones die, time seems to march forward. But on the right, you have the framework's claim. All those moments are just different frames in a static four-dimensional movie. What we call dynamics or change is nothing more than us comparing one frame to another. So how can both of these possibly be true? Well, to even begin to solve this paradox, we need a completely new way of looking at reality. And this is where the framework introduces two really crucial concepts, the territory and the map. First up, you've got the territory. The framework calls this the counter space. I want you to think of this as the real deal, the complete, static, four-dimensional source of everything. It's like a giant library that contains every single possible page of our universe's story, all at once. That's the counter space. But here's the catch. We can't get in and read the whole library at once. So what do we actually get to see? That's the map, or what the framework calls the shadow world. This is our familiar three-dimensional reality, the world we can see and touch and measure. It's like we're only ever looking at one single page of that giant book at any given time. Our entire world is just a projection, a shadow of that much bigger 4D counter space. And this brings us right back to our big question. What is energy? Well, here's the punchline. In this model, energy is not a substance. It's not some cosmic fluid flowing through wires. It is what's called a functional, which, is just a fancy term for a mathematical tool that does some bookkeeping. In this case, it's the calculation that tells us the difference between one page of our universe and the next. So let's go back to the battery. How do we use it? Well, according to this, both the fully charged state and the totally depleted state of that battery already exist in the counter space. Our experience of the battery running down is something called foliation traversal. It's basically our consciousness flipping from the charged page to the depleted page. The energy we get to use is simply the calculated difference between those two states. Okay, I know that is a seriously mind-bending theory, but what does any of this have to do with the real world? With building better technology? Well, the answer comes from a single, incredibly powerful idea that seems to govern everything from ecosystems to fusion reactors: the dominance principle. So, the dominance principle basically splits systems into two types. On the one hand, you have high gradient, or dominance regimes. This is where one major influence is calling all the shots. Think of a powerful river carving its way through a steep canyon. The path is stable, it's predictable, it's super efficient. On the other hand, you have low gradient, or interference regimes. This is where you have a ton of different competing influences all fighting with each other, creating a total mess, unstable, chaotic, and really inefficient. Now, this slide shows this principle perfectly out in the wild. Just focus on the graphs. On the left, we've got classic data showing the population of lynx and hare. See how clean that is? The lines go up and down in a beautiful, predictable wave. First one population dominates, then the other. That's a dominance regime. Now look at the wolf-moose data on the right. It is all over the place. A total mess, right? It's chaotic and unpredictable. And that's because all these external events, like bad weather or disease, are constantly disrupting the system, pushing it into an interference-dominated state. Okay, so if this one simple principle can explain the stability of entire ecosystems, could it also explain our biggest technological challenges? Let's find out. Let's apply the dominance principle to the world of engineering. Let's start with the holy grail, controlled nuclear fusion. Why is it so incredibly hard to achieve? Well, the framework says it's the ultimate interference problem. A fusion plasma has something like 10 to the power of 20 competing particles, all bouncing around. No single particle has any real say. It is a maximally low-gradient, chaotic soup. And the results? The exact instabilities that have plagued fusion research for decades. Now, contrast that mess with the battery in your phone. Why does it work so reliably, day in and day out? Because it's a dominant solution.
Chemical energy relies on these really well-defined molecular structures, strong chemical bonds that create a clear, high-gradient pathway for the reactions to follow. That journey from charged to discharged is stable, predictable, and efficient because one chemical path clearly dominates all the others.
And this is where it gets really interesting, because this way of thinking gives us a whole new roadmap for designing better tech. When we ask, how do we build better batteries, the goal actually shifts. It becomes about something called dominance invariance engineering. You know that annoying capacity fade we all get with our phones over time? Well, from this perspective, that's just the battery slipping into an interference regime, where these little unwanted side reactions start competing with the main one and messing everything up. This concept extends to even the most exotic technologies out there. Take superconductivity. We think of it as just zero resistance, but it's more than that. From this point of view, it's a unique state of matter, where a single coherent quantum state achieves total dominance over the entire system. All those messy, competing channels that would normally cause resistance and waste energy are just completely shut down, creating a perfectly stable and efficient state.
And wouldn't you know it, the exact same logic applies to lasers. A laser cavity is basically an engine that is designed for one purpose: to enforce dominance. It creates the perfect conditions for one single mode of light to completely overwhelm all the others. Every competing photon, every stray emission just gets suppressed. And the result is that beautiful, pure, stable, coherent beam, a perfect example of an engineered dominance regime.
So, you see, the principle really does seem to be the same across all scales. Whether we're talking about the cycles of nature, the battery in your pocket, or a high-tech laser in a lab, the rule holds true. Stability and efficiency come from dominance. Instability and loss, they come from interference. And this brings us right back to that initial, really strange idea of energy being just a calculation. The author of the source material, Henry Ariano Peña, puts it perfectly. He says, the irony is not that calculations are powerless, but that they are precisely what encodes the constraints of reality. In other words, seeing energy as a calculation doesn't make it weaker. It actually reveals the fundamental rules of the game we're all playing. And this leaves us with one final, and I think pretty provocative thought. As we face the enormous technological challenges of our time, are we even asking the right question? Is the future really about a desperate search for more raw energy? Or is it about getting much, much smarter at engineering dominance?